Hey, what's up, everybody? Thank you again for tuning in to online lesson 4, solving one variable equations and direct variation. So this is actually a 2-for-1 video. First part, we'll be solving one variable equations. The second part, direct variation problems. All right, the first problem we're going to end up doing is this one here. So determine the solution to the following equation. We're going to rewrite our equation first. So 6 times x plus 1 plus 4 is equal to 4. So I wrote down my equation. First thing you're going to do is you're going to want to simplify both expressions on the left and on the right. So look at what you could simplify. I see a set of parentheses on both, so that means I got to use the distributive property, which means I'm going to take this number, multiply this, multiply that, take this number, multiply that, multiply this. But I'm going to go ahead and draw my line straight down to know to separate my left from my right. And again, this is called the distributive property. So 6 times x is 6x, 6 times 1 is 6, drop down to plus 4. 4 times 2 is 8x, minus 32, minus 16. Now I'm going to combine like terms, so I'm going to look for my like terms. So 6 and 4 are like terms, negative 32 and minus 16 are like terms, so I'm going to combine like terms now. 6x plus 10 is equal to 8x minus 48. Now you want to choose the term with the lowest coefficient of x to do the additive inverse next. So again, look at your terms with the x and which one has the lowest x. So I got 6 and 8. 6 is lower than 8, so that means I'm going to move the 6x. So I'm going to do the additive inverse, which is minus 6x minus 6x. That gives me a 0 pair. Drop down to 10. That gives me 2x minus 48. Now I'm going to isolate the x term. So that means I need to do the additive inverse of minus 48. 10 plus 48 gives me 58, which is equal to 2x. This gives me 0. Now lastly, I need to isolate the x by dividing by the coefficient of x. So 2 divided by 2 gives me 1. Divide by 2 over here. So 58 divided by 2 gives me 29 is equal to x, or you can write it as x is equal to 29, your call. Now you can always take this and substitute it back into your equation to see if you did it correctly. Now I'm just going to go back and complete the notes. Do the additive inverse of the term with the least coefficient. Do the additive inverse to isolate x. And then lastly, do the multiplicative inverse to isolate x. Alright guys, so here's the second problem. Go ahead and hit pause so you could do this problem yourselves. Again, go ahead and hit pause. Alright, to go ahead and explain, the first thing I did was do the distributive property. Secondly, I combine like terms. Then I chose the term with the lowest coefficient of x, which was 4x, and did the additive inverse to move all my x's to the same side. Then I did another additive inverse to move my constants to the opposite side. And then lastly, the multiplicative inverse. Alright guys, so here's the third problem. Go ahead and hit pause and work this one out yourselves. Again, go ahead and hit pause. Now the steps were distributive property, then combine like terms again, then I selected the term with the lowest coefficient of x, which was -4 this time, so then I did the additive inverse. Then again, on here I did the additive inverse to isolate the x. Now, there was no need to divide by 1 or do the multiplicative inverse because we already have 1x is equal to a number. So our solution is this right here, or 1x equals 7. Alright, so we're moving on to the direct variation problem. Benny's family uses 5 boxes of toilet paper in a week. That sounds important. They have 30 boxes of toilet paper, I guess, in total. How many weeks do they have before they ran out of toilet paper? Assuming that they don't buy any within that time period. So the first thing you go ahead and establish is what is your independent variable. Or basically what represents your x, and your dependent variable the y. So as I'm reading this, it sounds like time or weeks is going to be your x, and the boxes of toilet paper are going to be your y, your dependent variable, because as the weeks go on, the amount of boxes of toilet paper changes. So this is going to be weeks. Y is going to be boxes of toilet paper. Now that we know that, we could go ahead and set up the following problem. So if I were to think of the following, let's make a table. So where x is weeks, Y is toilet paper. First week, or 0 weeks, they haven't used any. 1 week later, they use 5. 2 weeks later, they use 10. 3 weeks, 15. 4, 20. 5, 25. And lastly, 6, 30. So it looks like it will take 6 weeks to run out of toilet paper. Now, another way you could have also done it, they gave you 5 boxes of toilet paper. So this is your rate right here. So since you know your rate, you could have wrote your equation as y equals 5 times x, where 5 is 5 rolls of toilet paper per week. So you could use this, and then using your equation, y equals 5x, substitute the 30 into the y because that's the boxes of toilet paper, and then divide by doing the multiplicative inverse. 30 divided by 5 gives you 6 is equal to x. Alright, so here's another direct variation problem. Go ahead and pause the video, see if you can solve it yourself. Please read the question carefully and see if we come down to the same conclusion or answer. So go ahead and hit pause. So the first thing I'm doing is going to read it. Sarah's mom was stockpiling beans at the house. She had 4 bags. She had bought 4 bags of beans that weighed a total of 18 pounds. She went back a week later and bought 7 bags that weighed 31.5 pounds. What is the weight of each bag? So we need to figure out the rate this time. So instead of the problem giving us the rate, they're asking for the rate. Now, similar to the way we find slope, we're going to use change in y divided by change in x, or just your y value divided by your x value to figure out the rate. But we need to first establish what is our y and what is our x, what represents our dependent variable, which is the y, and what represents our independent variable, which is the x. So since I know the bags contain the beans, so the bags then thus give the weight. So the weight is dependent on the number of bags. So bags is independent variable, weight is the dependent variable. So go ahead and set up my first one. I know my original weight is 18 divided by 4 bags, which gives me 4.5. So I'm going to do the second one just to be safe. So 31.5 divided by 7. Let me make that look like a 7. 31.5 divided by 7 gives us also 4.5. So thus, each bag weighs 4.5 pounds. So if you wanted to write your equation for this one, it would have been y is equal to 4.5 times x. And if you wanted to check your work, you could just do y is equal to 4.5 times 4, which gives us 18. Y equals 18, so that matches our original problem, so that is good. Now again, thank you for watching the video. Please leave a like and a subscribe. Thank you for watching, guys.